Okay, so hello everyone. My name is Milan, and I'm a part of InterVenture for a couple of years already. I work as a front-end engineer in Addition team. I also saw there's some of people from Addition join, so that's a good thing, I would say. And yeah, we're working with Angular for some time already, since Angular 2. And yeah, I think I know something about it, but I guess each year I found out that I don't know that good, because every year or every month you learn something new with Angular. You never know how the things work actually. Let me just tell you how this presentation will look like. So firstly, I have like a couple of slides, which are not that important. They're mostly the basic definitions from Wikipedia, copy-pasted. I will focus more on the actual principles, and this will be a live coding session, which means that we will go through the code all the time. And hopefully the examples will be good enough to explain the principles itself. So there will be easy ones, standard ones, and I think that's, I guess, the most important thing if you want to understand the principles correctly. So let me just show you the project itself. Because you will be looking at this screen probably 90% of the time. So this is just a regular Angular CLI generated project. I have done already some changes because of our presentation. So as you can see in here, I just modified the schematics of Angular. So whenever I create a component or a service, we will create it in a, let's say, minimized way, so that we create only a single file with inline style and inline template, so without any tests, so that you can actually see the files on the left, so that it's not much of a confusion what we are doing. And also I turned off TS-lint so that you don't see this red flags around the screen, because I don't think it's that important for this talk anyway. So what else? Yes, I have actually for each principle, I defined a branch, which is actually showing the principle itself. Some of the principles are across the different branches, but that's not important. In the end, this will be shared on my GitHub account. And in the end, if you want to have the look at the end code, let's say, just let me know at the end of the presentation. So, okay, so let's start. Solid in Angular. So I need to go through a bit of these boring standard definitions, because I need to introduce what we are talking about actually. I guess some of you, probably most of you already heard about it and know principles. They used it and so on, but for those who are not, introduced to these ones, I would like to just say a couple of sentences. So the design principles we are talking about are just one set of principles, and there are a lot of them outside. These ones, I would say, solid ones are probably the most famous ones, and probably they're used quite frequently. So design principles are just recommendations how to design code in order to keep it maintainable, flexible, understandable. And what is the most important thing, that those are abstract. So you probably heard about design patterns, and design patterns are actually just an implementation of these mentioned above, of these principles, and then can be combined one or multiple, or because there are a lot of principles out there. You probably heard about dry or KISS, like don't repeat yourself, keep it simple, stupid. Those are the ones which are not part of solid principles, but they're also quite famous, and yeah, other famous developers talked about it, wrote some books about it, and so on. So let's just continue. What is actually solid? So it is an acronym. It's a shortcut for 5 design principles, and it is written by Robert C. Martin, or Uncle Bob. You probably heard about him. He wrote the book Design Principles, Design Patterns like 20 years ago. And I would say that solid principles are quite used since then. And I also need to say that these are recommendations. So these are not rules. these are not the things you need to use. These rules are not carved in stone, but they're quite recommended to use. And if you use them, you probably know why. So let's just, this is the last slide, and then we go to the code. So the solid principles, maybe you heard, for those who didn't, we have 5 of them. So for each letter in solid. So single responsibility, open closed, Liskov substitution, interface segregation, and dependency inversion principles. They all really sound complex, but when you see the examples of them, they're not that complex, I would say. And let's just jump to the first of them, and let's just jump to the code so that I don't want to bother you anymore with these slides. So S in solid, or single responsibility principle. This is a Wikipedia definition. Of course, there is a different for each of us. I guess it's a different meaning for this principle, but usually it means that there should never be more than one reason for a class to change. In other words, every class should have only one responsibility. We are talking about classes, of course. In Angular specific, it is TypeScript, so we have classes. But we have different entities in there. So we have, as you already know, services, components, directives, and so on and so forth. And of course, regular classes, which we use for our models. And let's just go after this to the code and see the example of it. Just a second. I guess I need to go outside of this because for some reason it won't change my screen. Never mind. Anyway, it is not that important. The code is. So let's dig into the code. So I'm on the single responsibility principle branch. And this is how the app component looks like. It's actually pretty simple. It's just a regular app. And in here, we are just having a single chunk of code, which is presenting just a regular, I would say, social network widget, in this case, Facebook. And on the click itself, we are just having some, I would say, pseudocode, because I didn't want to bother with implementations in this presentation, because we will have a lot of more time for that. We would need a lot more time for that. So, and this is how it looks like actually in the browser. So this is just a regular header generated by Angular CLI. And we have our widget in here. This is all, of course, mocked. So this is hard-coded, everything is hard-coded. And since we are talking about single responsibility principle, which is saying that a class should have only one responsibility and only one reason to be changed, let's talk about it a bit, about our component, root component or app component. So let's, usually when I think about this principle, because it is a bit tricky, and later on we will see why. But in this really simple example, let's just think about what this component is actually doing. So let's see. Firstly, it is showing the toolbar. Secondly, it is showing the content, and it's handling on-click. But also, and it's having its own implementation logic of on-click handling. As you already heard, we have already too many ends in our thinking, I would say, because this component is doing already a lot of things. So it has more than one responsibility. So let's just try to change it so that we are actually fulfilling the single responsibility principle. So firstly, what I can see in here that this part can be extracted to a specific component, because it's not a part of the app component for sure. It's a widget, right? So let's just try to extract it. I will just create a single component. This is the schematics I will be talking about. So I will just say something like Facebook, or yeah, Facebook widget. And Facebook widget is created. It has everything in line, so it's easier for you guys to see it. So let's just copy the template inside of this. Let's go to the component itself, move the click. We don't need on anything here. It is by default. And what is left is, yeah, let's just copy the CSS because so it looks decent at least, because now this is not a part of the app, but of this component. And of course, I will just minimize this so that you don't bother with that. And yeah, let's now just replace this with this component. Let's save it. Let's see our presentation. And yeah, as you can see, it is, yeah, everything is the same. So the application is working, but somehow we managed to move part of the reusability to different components. So in my eyes, this component is now only showing the toolbar and the content, and that's pretty much it. So I think I'm pretty satisfied with this one. But let's move to another one. So this is the Facebook widget in here. And the Facebook widget is doing what? So it is actually showing the content. It's handling the click, which is totally fine. It needs to handle the click, but it contains the custom implementation for the click. This thing shouldn't, I mean, it doesn't need to be a click. It can be some complex implementation. And I would say that this part of the code can be extracted to something different. So let's, in that case, just create a service in Angular and just call it something like, I don't know, Facebook opener. And just move this part of logic into our Facebook opener service. It will be called click, won't return anything, and this is pretty much it. And then you go back to the component, let's just inject the service. And on click, we will call the service. Let's save it. And when you go back to our application, yeah, so when we click on this, it is from the service and it is working. So this example is actually really, really simple, as you can see. But the reason I didn't go for the more complex ones, because this rule is a tricky one. Since in the more complex examples, you actually are not 100% sure when the responsibility of the first component stops and the responsibility of the second component starts. It's a bit tricky thing. What I usually do is just talk with my team members or people who I'm working with, and we just need to provide some kind of limit to this actual principle. Because if you use this thing all across your app, that the thing is already doing only one thing and so on, firstly, it's not really correct, since it's probably doing more than one thing. And after that, you will have a lot of files, a lot of code. So you will have a lot of redundancy, a lot of boilerplate code, a lot of files. After some time, you will probably, you could have problems with that. So I always use this principle, but I always use it to some extent. So just talk with people you're working with, and what makes the most sense for you, how to separate the responsibility, you do it that way. Okay, so this was single responsibility principle. After, when we finish all 5, you will see the example of the whole module in Angular, following all of these principles, and you can actually also see the single responsibility in action. So let's go back to our presentation. And let's move to the next one. And it is called, and solid, right? Open close principle. This one is, I would say, the ones which is frequently used all across, and I think it's pretty important, since it directly influences the maintainability of your code. So the definition from Wikipedia is software entities, classes, modules, functions, etc. should be open for extension, but closed for modification. What does that mean actually? Okay, so let's see it in the code. I will just shortly commit this because this will be the end of the first principle, and you can later on check it. On my GitHub, just fastly push it, and I will just go back to actually move to the open close principle. Okay, so let's dig into this example. What does it mean when the definition says something like, yeah, your class should be open for extension but closed for modification? Let's see this example in here. So right now we are having, I have created a social network widget in here, which is actually just a parent component of, in this case, Facebook content and Twitter content. Those are just two social network widgets. And I'm showing it in the app. So let's just see how it looks like. A second. Yeah, it looks like this, doesn't matter. But we now have the two social networks shown in here. But what if we want to add one more? It can be Google Plus or it can be an Instagram, it doesn't matter. But we want to actually add additional functionality to our component. And I just provided a regular solution, a standard solution for this case. I just have two ngIfs in here. I'm just saying, okay, if you provide me Facebook as a type, I'm showing Facebook. If I provide Twitter as a type, I'm showing Twitter. And yeah, this will work, right? Because it works. So both of those are shown, and in the app itself, we are just saying which type it is. But imagine now, what if I want to add a different one in here? Third one. And I say this will be Instagram, right? Then I go into my code of my parent component, and then I know then I need to add additional code in here, which means I'm violating the rule of the open-closed principle, which means that I am actually modifying the parent component in addition of a new feature, which is wrong. And this means that this thing is not fulfilling the principle, right? I would need to do something like this and ask if this is an Instagram, and then add additional stuff in here, right? And I changed its source code in here. So let's just provide a solution in which we will fulfill the open-close principle, at least with Angular mechanisms. So what I can see in here, firstly, I don't need type anymore. I will just delete this thing. Or maybe I will need it later on. Let's just, yeah, I will need it later on, it doesn't matter. So as you can see in here, I will just remove this, and this is the actual HTML of my widget. This thing should be dynamic. So let's say that this should be a title for our social network widget. Let's say a title in here. We will provide it as an input, but what about the content itself in here, right? So what we should do with that? Let's just remove it. Let me just a second. I want to have this copy pasted, just a second, because I don't want to copy paste it again. So there is a thing in Angular called edge content. You probably, if you use Angular, you probably use it. If you're not, yeah, this is the introduction to it. Edge content is actually dynamic rendering of the content, and with some Angular magic, it fulfills the content with the content you provide as a child of your HTML. HTML component in the template. So for me, this thing looks good enough for now, right? And let's try to use it. First, we don't have type, right? We have title. Let's just put something like this. And in here, I will just put this content in here because I need it. Then I will delete it. So I need the content of the Facebook. Let's delete this. And I have a content of a Twitter. And as you can see, application is still working. I just changed the approach in here. I'm providing the content in here dynamically. And we can go one step ahead and just extract these two different components. Let's just do that fast. So first will be something like Facebook content. And second will be Twitter. Let's just copy this part of the code, which is the content of our first social network widget. Go to the Facebook content and put it in here. And for the Twitter, we do the same. And yeah, what we need is we actually need to copy the styling. So the styling looks the same. Just a second. So that it's not broken. Just minimize it. And also for the Twitter content, because we moved the HTML, right? And after all of this, when I actually try to use them, Facebook content, that's it. Twitter content, that's it. Let's go to the browser itself. Let's refresh it. And if you take a look in here, this is actually the same thing we just created. So with the Facebook content, Twitter content. But what is now the difference with this approach? I could add a different one in here. I can actually add like 10 of them, right? But whatever I specify in here is dynamic. I can add a different component. I can even add just a regular paragraph, something like new widget is coming. And something like, I don't know, test. This is D in here, sorry. And it is there. So the thing is, it's not seen because it's CSS, of course. Let's do something like H1, maybe it will see. The thing is that, yeah, but the thing is that whatever you provide as a content, it is rendered, right? And with this approach, we can add how the endless number of new stuff in here, of the new types of contents, and we wouldn't change our network widget in here, right? Because this component is now open to extension, but closed to modification. We didn't change any of its code. We are just extending it and using it in here in various places. We can use it in different modules, doesn't matter. We can provide whatever we want in here. And it will just work as the first solution we provided. But this one is just following the open close principle. This is open close principle applied to actual component level. Later on, I'm going to show you actually how to do it with services, abstractions, and so on. So let's just go back and to the slides and just go to the next one, because I think I already spent a lot of time talking. Yeah, Allen solid or least code substitution principle. Functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. This looks like, when you take a look at this default definition, a bit complex. But actually, what it is about, you can imagine that you have one base class and you have maybe a couple of derived class from that base class. And this rule says that if you replace the base class with any iteration of its children classes, your application won't break. So it is totally replaceable. The parent class is replaceable with any instances of their children classes. This principle you can actually implement on whatever thing you want. I will just shortly show you in just a basic example in TypeScript how this looks like. But stay tuned for that. So let's just call something like, I don't know, abstraction.ps. And let's just create a regular example. So you already know about the streaming platforms, right? Is it a Netflix or, I don't know, Amazon Prime or whatever? You have users in there, right? You have subscribers. So you have a standard subscriber. You also have a premium subscriber. So let's just create those just for case. So we have a premium subscriber. And we also have standard one. And when we take a look on this, like logically, these two subscribers are actually having something in common, right? And that's why we're gonna create a base subscriber. Let's say that it has something like name. It doesn't matter. And let's add some kind of behavior for premium and standard subscriber, something like watch premium content, right? And something like, I don't know, watch premium. And we can also create something like watch standard content. So think about this. I started with the presumption that base subscriber will be enough for both premium and standard subscriber. But let's go more through. So premium subscriber will extend base subscriber. And as it is, it will have watch standard content, and we also have watch premium content because it's a premium subscriber. But what about standard one? Standard subscriber actually cannot watch premium content, right? Because of that, I will do something like this. Cannot, or something like unsupported, right? Or how is it spelled? I don't know, unsupported. So now when you take a look at this code is actually violating the least code substitution principle because base subscriber can be replaced with premium subscriber. But when base subscriber is replaced with standard subscriber, error can be thrown and our application is off. So the solution for it will be, obviously, if you don't throw the error in here, you can do something else. But the idea is that this model is not good enough. So what is the actual solution to this one, in my eyes, is that if you want to provide this least code substitution principle, you need to be careful of what you put in your base class. So for the first type of solution will be that you move the implementation or behavior to actual subclasses in here. And with this approach, you don't have anything in base subscriber, but with this approach, we are actually fulfilling least code substitution principle. Because whenever you replace base subscriber with those two, the application is working, right? So you don't have anything which will break it. Or another solution would be that you actually extract these things to interfaces, which will be our next topic. But you can extract these to interfaces and then implement interfaces, something like this. So I can do something like extract interface standard. If let's say, let's just prefix it with I don't want to just export, sorry. And something like E standard, it will have just something like this. And we will have E premium. And this one will be handling premium content. So with this approach now, we can actually say that premium is implementing both of these. And the standard one is implementing only the standard. And this one, of course, need to implement all of this. But this is one of the I would say, decent approaches in this particular example. So I think the idea is that whenever you think about your models, if you want to fulfill the least constitution principle, you need to think if your derivative classes actually can replace your base class without breaking it. Which brings us to our next principle, which is interface segregation principle. This one is pretty, I would say, spread around since it is used quite frequently, at least in my environment, that the many client-specific interfaces are better than one general-purpose interface. Or if you wanted to actually have a different definition, is that consumers of your interface shouldn't be able to have behaviors which they don't need. In this case, in here, I could create something like, and then have a single interface for both of these. Oh, sorry. So the thing is that I don't need watch Chromium content. So I don't need this. I don't want to implement interface which is having this type of method because I don't need it in the sender subscriber at all. So the idea is to have small, lean interfaces and that your consumers of interfaces are not having methods or behaviors which they don't want to use. So I don't need this in here. Or I will throw an error like something, it's not supported. So if we use this, then we are actually violating the interface segregation principle. But if we use, as we did it before, in here, when introducing actually two interfaces so that anyone can actually take the behavior which it's needed for them. So for premium, it's needed both of them. And for standard, it's needed only standard. And that's, I would say, it's the idea about this principle. Okay, let's go to the next one, which will be the last one, but I would say the most interesting one. So next one is the insolid or dependency inversion principle, which means depend upon abstractions and not concretions. Yeah, this one is pretty, I would say, wide because this one sentence doesn't tell you a lot, right? And let's see it in the code because that's the best way to actually show it. Okay, I will just like last time. I will just commit this stuff I did on the open close principle because it contains all of them. Second. And let's just go to the dependency inversion one. Or actually, let's because we have time, let's just go back to this previous one and just write it through because we have time to do it. I wanted to actually show you how it is done, but I will rather now actually, since I have time, let me just see how much time we have. Yes, so I will be fast, Tamara.
Don't worry,
okay.
take your time.
Okay, so let's go to our Facebook, social network widget. Let's close it. You already saw how it looks like. Sorry for this because I'm new to Mac, so this is a bit slow for me, changing the stuff. Okay, let's see what is wrong. Probably because changing of the. Let's just run it once more. Yeah, these things happen when you live code always. So sorry for that. But now we are fine. Okay, so we are back. Let's go to our app component. Let's remove this one, we don't need it. And let's actually try to explain the dependency inversion principle, which is, I would say, maybe the most important thing when it comes to creating Angular modules. So first of all, our social network widget in here, right? So what if we want something like for each child ng content component, we would need to trigger on init some kind of action, like click on it, right? We can do that. So let's see how we can do that. Firstly, we will implement in our children components something like we go to abstraction. I want to create an interface for clicking, something like clickable. And this will be having only one single method, which is click, and it's type void. And both of our content components are gonna implement those. So it is clickable, which means it needs to implement the member. We don't need this. And something like, yeah, so let me remove this. And let's just log something like Facebook click. So that we know when we click that it's a Facebook component, right? And let's go to the Twitter component and do the same. We don't need this, but we need click, and it's actually Twitter. Click. Let's go back to our widget component. So what we want to do, we want to actually on init of this component, we want that each of our content components trigger a click because we need it. It doesn't need to be a click. It can be any other event or action. But in this case, I think it's good because it's simple enough to show the example. So let's see how we can do it. Firstly, in Angular, in order to actually find its proper child, you can use content child because in this case, use ng content. If you use something else, you can use some other decorators. In this case, it's content child. And in our case, it will be like Facebook content component, right? It will be Facebook content. And for Twitter, it will be Twitter. And then on init, we are saying something like if Facebook content, because it has publicly available method. And same thing, we go with Twitter We just need to put something in here because we're using it on init, and content is actually ready after content init lifecycle methods. So we need to put a static true in here in order to have this content available on init. Let's check our add component. We have Facebook, we have Twitter, and let's see if everything is going well. Yeah, so when this is initialized, we're having 2 clicks on Facebook and on Twitter. So we automatically trigger this. But actually, even though this is working, we are depending on concretions in here. And we are violating the dependency inversion principle, which says that your classes, in this case our components, need to depend on the abstractions, but not on concretions. And how we do that? First of all, I'm not too familiar with, but in Angular, there is no possibility to actually inject abstractions. There is a mechanism, so you can provide actual token in which that token is later on replaced with your implementation. And that's actually quite strong and quite powerful mechanism, which I will show you right now. So because what I can see in here that both Facebook content and Twitter content, they're both clickable, right? Since they're implemented in the interface. So let's try to create some more abstractions in here. So we just need this interface, and let's do something like this. So I want to create my clickable content, which is an abstraction. And this will be an injection token. And this is just a description. We can see something like clickable content. And in here, we will say that this type of injection token is actually, we need it for clickable. By using this, now we can actually provide an abstraction and later on inject the concrete or provide a concrete implementation for this. How this works. So what we can do now in social network widget is that instead of this, because we had 2, right? Now we don't have 2. We have only 1 because both of them are actually clickable. And in here, since we cannot use abstraction in here, we can use a token. So we can say that this is clickable content. And let's just replace this with this content. Content dot click. And what we need to do now is to provide a provider for this abstraction. And what are the providers for these abstractions? They're actually clickable components. So let's do that. Go to Twitter content. After this, I can say providers. I can say provide clickable content and use, we need an object in here. And we need something like use existing because this is the component which is already injected. And we will say something like Twitter content component. And the same thing we will do for Facebook. And that's it. So let's see if it works from the first try. Oh, it works. So we automatically clicked on both of them. But when you look at the social network widget in here, do you see any concretion in here? Because we followed our 5th principle, dependency inversion, and we are depending only on abstractions. how this works actually is that this injection token is a mechanism on Angular, which will be in a way to actually provide the runtime representation for abstractions which you cannot directly inject. In this case, we're just saying, okay, this is a placeholder, this is our abstraction, and this component is actually inject this component when it's needed. And that's pretty much it. So this is the dependency inversion principle in a nutshell for the components. But let's do it one step ahead, because I think I already spent a lot of time, but I think I have enough. So let's just do something even more interesting. Okay, so let's, for example, move all of this to a module. So I will create something like social network module. Okay, I don't need this. And this social network module, oh, actually it is, I created the component. Second, yeah, so let's just delete it. We need to just remove it from our application module. And this will be okay. So let's generate it once more. So like module, and just let's call it social network. And here it is. This is the module. So let's move our abstraction and our social network widget, because these are our abstractions, and these are actually the main point of our logic. And we need now to remove the social network widget from our add component, and we need to introduce it in here. So it's a social network widget component. And of course, we need to export it in order to use it outside of this module. And when you then when you go to a component, it will say, okay, I don't have it, right? So we need to import it into the module itself. And now, in theory, take a look on this. It works. So we just move everything to our social network module. And this is a good thing about Angular. If you actually create a module with your code inside of it, you can always just import it into your own other module and just use it. So I guess this is a good thing. Just let's do the last step. But I think that I will just go to the next. I will just commit it and go to the next branch because I think I'm run out of time. So let's just, I will show you what I did next. Let's just commit it. A second. And let's just open the dependency inversion. We have the same logic we had in there, but we had one more thing we added. And then I will show you what we added. Let's just collapse this. Okay. So what I wanted to do is to use an actual service to do the reload on the on-init for all of my children components, right? And in order to do so, I firstly introduced the reload service, which is just saying reloading, and that's it. But later on, I needed to actually to fulfill the rule of the dependency inversion, and I need to depend on abstractions. So what I did is that I created also the reloadable provider, which is another token. I created the abstract reload in here. and I use that provider in my social network widget component. And on init, I just click reload. And what is most important thing is that this is used all inside of the social network module. So in the social network module, we have an abstraction of the service and we have the concretion. And we said that in this particular module, we use a specific class for that. But why would we want to do that, right? The idea is that whoever consumes this module, which is in here, can use its own class. So look how this powerful is actually. This is maybe the most powerful thing about Angular, is that if you create and you depend on the abstractions in your modules, you are free to import that everywhere in other modules, but also extend and or change its behavior. So let's just show that in the app itself. We don't need this. So we just imported the module, and you see that it's saying reloading, reloading, which means that for both of our content components, just a second, social network widget. So for both of our content components, we are actually clicking reload. And if you see, this is the abstract reload, right? And when you take a look on the reload service, this is the default implementation. So if I import that module inside of my module in here, I will have the default implementation, and this is reloading. But if I want to actually change it or enhance it, I can just do this and provide my own service. And this is actually the best thing about these abstractions and injection tokens. And by using this in my custom service, I can use something like, I can do something like, just a second, what I did in here. I can actually provide my custom implementation and also use the old one. So if I say something like this, my custom reload is there. But what is most important, we didn't change anything in our social network module. We just used our own class in our app module and just provided it for the specific token and abstraction. So in this module, just to finish this quite quickly, your module of social network is based all on abstractions. There is no single concrete class in here, but also it is open to extension and closed for modification. So in this case, we also followed rule open closed. We followed rule dependency inversion. We use interfaces properly. We use single responsibility because our module in here is only responsible for the social network widget and nothing else. So that's why I said this first solid principle is a bit tricky. And this is, I would say, the power of Angular. And these rules are the rules which Angular uses quite frequently. And let's just go on a couple of examples on Angular code. So there is this, you probably use it already. It's called app initializer. And this is the thing we did actually. It's the same thing. So app initializer is just a token. And if you want to add an additional logic or actually extend it without modifying it, you can use this and provide your own factory and log, in this case, custom stuff, but you can do whatever you want before the app is loaded. So what we see in here is that Angular followed both open closed and dependency inversion principle in its own source code. And then I can go back to this here and you can see that custom stuff is loaded. So we can either keep the same behavior as the default one, we can enhance it and on the default behavior add additional one, or we can totally replace it, at least in our case of social network. What else I just wanted to show you is that this is the same principle as for the HTTP interceptors. If you go there, you will see that this is the same injection token as we used again. So this is an abstraction. Angular depends on abstractions. And you can provide your own interceptor, which will either keep the old logic and add additional work or totally replace it. And what else I wanted to show you regarding Angular is that in the app with components itself, you have these lifecycle methods, which are used everywhere, I would say. But if you take a look on its implementation, you will see that each of these interfaces are following interface segregation principle, because they are simple, they all have single method, and whoever wants to actually add a behavior to it, it can use it. Imagine if you have like a single interface with 6 or 7 lifecycle methods. You will have a lot of unused methods in your components. And this is just a showcase that even though these are recommendations only, Angular really heavily depends on them. And Angular in its source code uses all of these principles. And I think I am run out of time. And I think that actually will be everything I wanted to talk to you guys today. Thank you for listening. And hopefully I was clear enough. And yes, sorry if I missed something out, but I think this will be everything. And yeah, Tamara.
Don't worry, Milan. Don't worry about the time. You can finish. You can finish if you need something else to wrap it up. Also, we have a few questions. Do you want me to read it, or do you want to read it yourself?
Which one is this one? I'm looking at it.
Yes, we have one from in a Q&A option with the single responsibility question.
The second, if we have a shopping cart and need to get shopping cart details to specific user.
How to make a decision? Is it the responsibility of the user service or a shopping cart service?
I would say that if you want to be more lean, I would say you need to the logic itself for getting the data about the concrete user. I would put that inside of a service. Because if you want to change something in there, you will need to change just a service and your component is using it. So you wouldn't change anything in the component, right? So I would put it in the service.
Okay, thank you. And there is one more question from Goran in a chat box regarding Liskov sub-principle. I will read it for other people who are not maybe seeing it. This is more on the side of single responsibility. LSP is more about not breaking what is this name? Environs.
Liskov substitution principle.
Yeah. Can you discuss about return values and arguments with regards to Liskov sub principle?
Yeah, I know what he asks actually. Yeah, well, to be honest, I didn't dig that deep into the Liskov substitution principle because so far my models were just good enough to be used with the basic examples. Returning values and arguments, not sure what you actually mean with that. Can you explain to me? Because I'm quite interested what you meant by return values and arguments with regards to Liskov substitution principle.
Goran, if you would like, I can. Yes, of course. Yeah. There you go.
Just a second. Can you hear me?
Yes, we can hear you.
Okay, thank you very much. First of all, thank you for the presentation. And this is very new to me to hear about solid principles from the Angular perspective because I don't know anything about Angular. And my question about LSP is maybe you remember that example of rectangle and square. And if you have a square class and rectangle class, which one should inherit the other one? So this is the classic school example for Liskov substitution principle. And I think it's not about methods that are not implemented, because, okay, that is a problem by its own. You can even have all the methods in derived class implemented, but yet again, and if you watch separately these classes, they are quite okay. But if you watch the relationship between these two classes derived in the base class, then the invariants are broken.
I know what you mean.
Yeah.
The thing is that I see this principle as, to be honest, I didn't at all think about that. Let's say approach you're talking about, because I was always thinking about the relationship between my base classes and my derived classes, and that I need to think about them if I want to follow these principles. I need to think about the model itself if I don't want to actually break my app, right? Mm-hmm. But what you actually talking about, to be honest, is a totally different perspective of what I actually use this principle for. Maybe I don't know. I
don't want to postpone these with my question. I've just pasted a link for anyone who is interested. So I mean, we can discuss later on if someone else have another question. There is an interesting article about this example that I mentioned, and the broken invariants. That can happen very often, and it's not so so obvious, so to say. So not implemented methods are pretty much obvious things. But broken invariants in inheritance relationships are not so obvious. So it requires much deeper analysis. I mean, okay, yeah.
Keep just if you have some article you can just send me.
Maybe it can be seen. I'm not quite good with this Zoom thing. I hear is on the chat probably. Yeah. Thank you very much again for the presentation.
Yeah, you're welcome.
Thank you, Goran, for your question. There's quite a discussion in a chat box here. Darko was asking, why did you use a content projection? Okay.
Well, I use content projector because this is the way you can put everything inside of your wrapper. I know that in some case, you can repeat stuff, right? But this was just a use case. It was just a social network. What if they're not social networks? What if you need to provide a content which is totally different from each other? They're not shared any model at all. What I will need to provide a different input if I can just put whatever I want in there. And this was purely for solid principles. Yeah, don't repeat yourself is quite a nice one, but I would rather go in for solid ones than for dry. That's my personal preference.
Okay, thanks, Milan. Do we have any more questions? Okay, Nicholas, you're adding something. Thank you.
And the thing is, just one more thing. The thing is that you said that you want to put a wrapper widget around. But the thing is, if you do that, then this whole thing is not extendable anymore. You are forced to use the proper input in there then. So then my solid principle, or actually my open close principle, is broken. Dry is, on the other hand, probably followed, but my open close principle is broken. So that's why actually. And I focused on these particular principles to be fulfilled. This is just a basic example. In the end, you can enhance it even more to not be repeatable. But yeah, I guess it is always a way to make the code better, especially if you're having more time to do it.
Okay. If we don't have any more questions, maybe we should wrap it up. Thank you everyone for coming and participating in this Angular Tech Talk. Milan, thank you for your presentation. I mean, people are really interesting to hear more about it, and they're just posting a great thank you notes in chat box. You can follow our LinkedIn page and social media for news and open positions and future events. And as I said, the recording of this Tech Talk will be available on our YouTube channel tomorrow. I hope you enjoyed it, and have a nice evening. See you. Bye-bye.
Bye, guys. Thanks for listening and
Thank you.
asking. See ya.
Thank you. Bye.